Operation. Standard PLCs perform a three-step operation called a scan, which consists of reading the input status from input devices, executing the control programs stored in memory, and then updating or writing the status of the output devices based on the outcome of the control program execution. And a PLC performs this scan over and over again, constantly updating the outputs based on how new input conditions affect the control program. This operation occurs in a synchronous, repetitive manner. Input devices that can be wired or connected to a PLC system can be discrete or digital devices that provide an on or off signal. These on or off signals in discrete systems are related to 0 and 1. 0 when the device is off, and 1 when the device is on. Other devices that connect to input interfaces are analog devices, which provide a value signal, which may be in the range of 0 to 10 volts DC, like a signal coming from a pressure transducer with a transmitter which provides the voltage proportional to the pressure that it is measuring, for example, from 0 to 3000 psi. The same applies to output devices that can be wired to output interfaces. They can be discrete, on or off devices like solenoids, motor starters, indicating lights, and others, and can also be analog field devices like control valves that receive, for example, a 0 to 10 volts analog voltage to control the opening of a valve from 0 to 100%. When the PLC is running, it reads the status of all the inputs and executes the control program, or the logic, that will drive the outputs. And when the program execution is finished, it will update the output modules, turning on or off the outputs, or sending the analog value to an analog field device, like a control valve. For example, when the PLC is placed in the run mode, the controller will read the status of the limit switch, LS1, which is connected to an input terminal of an input interface module. If the limit switch is activated, it will provide a voltage to the input module signifying that it is on. In PLCs, as well as in ControlLogix talk, we say that the limit switch status is true, or on, or logic 1. This value is stored in memory in a location that stores ones and zeros, or the on or off status of the input device. In the case of the limit switch, let's say that the 1 or 0 is stored in a memory cell named LS1. Then the controller will read the status of the next input device. Let's say that it is another limit switch named LS2 connected to an input interface. And that LS2 is also activated so that the signal provided to the input module is on or logic 1. The controller will also put a 1 in the memory location that references the limit switch LS2, and so on. The controller will continue reading the status of all other input devices. In the case of an analog device, the controller will read the voltage through the analog input module and store the value in a memory location. However, the data stored will use more than one memory cell to represent that number. We'll see more on this later. For example, if the analog voltage being read at the input module is 3.85 volts, then the controller will store 3.85 in a memory location that references the pressure input field device. Once all the inputs have been read and their information stored, the controller will start its control program execution, which is the running of the control program in a PLC language like ladder diagrams, which we will cover in detail later. However, for the purposes of understanding PLC operation, let's review a simple ladder control diagram. Let's say that there is a ladder logic in the controller that specifies that if the limit switch LS1 is on, and if LS2 is also on,